Alrighty.
Yeah.
So, welcome, friends, to this wonderful lecture that's going to be given by Dr. Thomas Herrington, and I'm going to introduce him and give him a brief bio about him in just a second. But I did want to say that this lecture is being sponsored by the American Library Association. I'm Judy Unger. I'm one of the librarians at Brookdale. So, hi, everybody. Don't forget to make a research appointment. Just wanted to throw that out there. But one of the things that I did over the summer was to apply for a grant from the American Library Association that talks about communities and climate change. And our Brookdale was very fortunate to have won a grant from the American Library Association. So this lecture is being sponsored by the American Library Association. So I just wanted to mention that. So let me get started by giving a little biographical sketch about Dr. Herrington. And then I am going to let him take it away. Okay.
Okay.
So this is Dr. Tom Herrington. He is from Monmouth University Urban Coast Institute. He is the Associate Director of the Urban Coast Institute at Monmouth University and serves as the New Jersey Sea Grant Consortium Coastal Community Resilience Specialist. Try saying that 5 times. Dr. Herrington has 30 years of experience in coastal resilience and hazard mitigation research, including the monitoring and analysis of coastal system changes to storm surge and wave impacts, and the analysis of nature and nature-based features for ecosystem restoration and community resilience. Prior to joining Monmouth, Dr. Herrington was the director of the Ocean Engineering Graduate Program at Stevens Institute of Technology and the director of the New Jersey Coastal Protection Technical Assistance Service, where he developed and evaluated coastal protection systems for New Jersey. He has authored or co-authored over 100 journal outreach and technical publications in the field of coastal and ocean engineering, including a framework for prioritizing coastal ecological adaptations in New Jersey, and as a contributing author to the book Blue Dunes, Climate Change by Design. Through the New Jersey Sea Grant, Tom is presently coordinating community science projects on the quantification of sea level rise-driven nuisance flooding for informed coastal resilience decision-making.
Wow.
That's Dr. Herrington in a nutshell. So obviously he's a pretty busy guy. So thank you for taking time out, Dr. Herrington, and take it away.
All right. Well, thank you for having me, and thank you for the introduction. So I got to share my screen. That's where we'll start, right?
Mm-hmm.
Okay. Can we see that?
Yes, I can see it.
Okay. So the work I'm going to discuss today really is an outgrowth of the work we've been doing with coastal communities in New Jersey through the Sea Grant program. And if you do live on the coast, you may have noticed, like many of our coastal residents, that it seems like the streets flood more frequently than they had in the past. And that's not a misleading observation. And we see that climate change is driving sea level changes, which puts the land much closer to mean sea level over time. And it just takes a little bit of a storm surge now to flood some parts of our communities. So I'll talk a little bit about sea level rise in general, globally, what's driving it, what we think is most likely going to happen in the future. Then look a little more locally at what's happening along the coast of New Jersey. And then discuss a little bit about what we're trying to understand in terms of rainfall and sea level rise flooding. So that's something that we're just starting to collect data on, because in the future, we think that the joint occurrence of those two things will be problematic for our coast. So I want to start by, and now I'm going to have to see if this is going to work. I'm going to have to jump out here. Our friends at NASA did this really cool little animated video. So I got to stop share for a second. Sorry. Oops.
We're all used to this as teachers.
I know. I'm going to jump out and share. Okay, this should work, I hope. This is it. Okay. And of course, it's not. Can you hear that?
Yeah.
Okay. But we can't see it.
It's very low.
It's very low volume.
It is quite low.
Let's see.
We could hear it as if it's playing through your computer, but it's not projecting to us.
I see. Okay, hold on. Wait. Oops. I know the problem there. Sorry about that. One of the problems is I can't get.
In chat, I think there's an option to share audio. And
Yeah.
then it should play that way.
Yeah, usually I can see that pop up. So share audio in chat.
But
Let's see. Oh, I see.
No,
Share sound. Let's try this.
NASA has
Better?
observed the Earth getting warmer
Okay.
and the sea level getting higher. What's the connection? Just like mercury in a thermometer, water expands when it's heated. And Earth's ocean is taking in more than 90% of the heat from global warming. That's a lot. Water temperatures also cause a lot of the ice melt. It ends up in the ocean. A child born today can expect the ocean to rise between 1 and 4 feet in their lifetime. In the United States alone, nearly 5 million people live within 4 feet of the local high tide level. That could mean increased flooding from storm surges. And as the ocean rises, its salt water can mix with our rivers and groundwater, which is where many people get fresh water for drinking and farming. So there's no question that sea level is rising. NASA can measure it from space, but what are we going to do about it? Some communities are taking steps to adapt, and others are working to address the cause, global warming. It's a big challenge, but hey, we'd better be up for it, because right now, good old Earth is the only planet we've got.
So the reason I like to share that little animation, one is to really gives you a nice kind of imaging about what we're looking at in terms of sea level rise, right? And that's not this, wait. So that should have stopped that share. Okay. And so one of the key elements of that is the fact that as the Earth has been heating over the last century, 90% of that heat has gone into the oceans. And so what's happening in the oceans is pretty profound. And the first being that heat causes the water in the ocean itself to expand. So as the average temperature of the seas increases, we see a thermal expansion or a eustatic sea level change in the oceans. And if we look at it right now, that's almost 1 millimeter per year of sea level rise just from the ocean warming and expanding. That warmth in the atmosphere also we know is melting our glaciers. So the glaciers that are on the lands like Greenland and Antarctica, those, as that ice melts, it enters the sea and contributes another 0.6 millimeters per year roughly to the sea level rise change. And then at land over ice, or this we call just ice and snow on flat lands, actually, as it melts, it contributes quite a bit, 1.1 millimeters per year. And then we have riverine inputs, and they're a little bit more variable, but as precipitation changes around the globe, we're seeing an increase in the amount of freshwater influx into the oceans itself too. And so if we combine all these elements, wrong way, we find that right now the seas are rising at about 3.2 millimeters per year, roughly, from those elements. And the question is that going to stay static, or do we expect that to increase over time? And I'll talk a little bit more about that in a few minutes. So if we look historically at sea levels, one of the things we notice right now, our sea levels have been, from a historical perspective, over the last 20,000 years, pretty stable. They haven't really changed that much. But if we look back at the last ice age, we notice right away that sea levels were, whoops, sorry about that, almost 400 feet lower 20,000 years ago. And so as the glaciers began to melt, they put a lot of water into the oceans. And it wasn't always linear or constant. We see these, what they call meltwater pulses, that occur at certain periods of time where there was a rapid increase or basically ice collapse occurring at this time during our movement from the last glacial maximum into today's climate. And so sea level fluctuated quite widely at times in the recent past. What we're looking at, actually, I should explain before we get too far, is that these are corals. These are prehistoric corals, or not prehistoric, but they're corals that they find in different places around the oceans. And we know that corals can only grow within a certain depth from the surface of the water. And so they're using the corals as a reference to prior sea levels. And so we see that these very deep corals that they find, they're dead now, but the existence of these deeper corals at one time indicated sea level was much, much lower. And then we can see, as we get into the last 6,000 to 4,000 years, we have this very almost stable sea level that we've been living with for some time. So 21,000 years ago, the Jersey Shore was actually 100 miles farther offshore than it is today. So you'd have to commute a good hour to get to the beach from Brookdale at that time, right? And so, that represents sea level stand of 400 feet lower than it is today. And if we look at the last time the Earth was ice-free, we have to go all the way back to 110 million years ago, to the Cretaceous period, where there was no ice at all. And at that time, well, you can see that the continents were not in the same place they are today. But the sea level at that point was 330 feet higher than it is today. So there's this almost 700-foot range in sea levels that we've seen on the globe in its history. At the time of the Cretaceous period, the carbon dioxide concentration was 1,000 parts per million in the atmosphere, and the average temperature on Earth was about 80 degrees. Today, as a comparison to that, the carbon dioxide concentration as of February 7th at Mauna Loa Observatory in Hawaii was 417 parts per million, and our average temperature is about 60 degrees. To give you an idea, last time I gave this presentation was in October, and the concentration of carbon dioxide in the atmosphere actually increased 6 parts per million since then. Some of that's seasonal fluctuation, but we've seen this tremendous change and increase in carbon dioxide in the last decade or 100 years. So, oops. Seem to be, oh, there we go, back up one. So if we look at New Jersey in the Cretaceous period, so this is an elevation map of the state of New Jersey. All the colors that are in blue and light green would be below 330 feet. So they would be underwater at that time. So most of New Jersey in the Cretaceous period was the ocean, the bottom of the ocean. And what is really interesting is if we take a look at this Haddonfield, New Jersey, Haddonfield is a very interesting place because it's the site where the first fully reconstructed dinosaur was excavated in the 1800s. And it's called a Haddosaurus, named after Haddonfield, of course. And the Haddosaurus, most paleontologists agree, drowned in the shallow seas off of the coast of the US or North America at that time. And so the paleontologic history is telling us that indeed we would have expected to find coastal oceans over New Jersey in the Cretaceous period. So what's happening today? So today we're seeing, again, this kind of really dramatic ice melt all across the globe. And when we look at certain areas, we know that the Arctic actually is heating the fastest, as the Arctic itself is heating faster than any other place on the globe. And the result of that is that the winter, or I shouldn't say winter, summer extent of frozen sea ice has been decreasing. And this past summer, we actually hit the minimum amount of covered sea ice in the Arctic that we've ever recorded. And so we're thinning the ice caps. I think you may have heard of that. And it's happening very rapidly, more rapidly than we had expected, which is a concern. More locally, what has sea level been doing? So one thing we're lucky to have in the United States is a tide gauge network that was established about a century ago to help with navigation in and out of our ports. We have a tide gauge that's on Sandy Hook. It was installed in 1911, and so it has about a century of data. Hurricane Sandy actually destroyed it, so we did lose about a year's worth of data after Sandy, but they've rebuilt it. And if we look at this graph is showing us the monthly mean sea level that was recorded at the station since 1930 to 2020. And if we just put a linear trend through that monthly mean average, we see that the sea levels in Sandy Hook or off Sandy Hook have been increasing by about 4 millimeters per year. And so now that's a little problematic, right? Because I just told you that sea levels are rising at about 3.17 millimeters per year due to all the different climate change forcings. But actually, we're a little bit unlucky in the sense that we never had an ice sheet above us during the last glacial maximum. So as far as the glaciers got in the last maximum phase was about a little bit south of Manhattan. And so that ice sheet, which was hundreds of feet high, all that mass pressed down on the Earth's crust. And as it did so, the areas outside of the edges of the ice sheet actually were bulged upwards. And so as those ice sheets retreated and melted, all that weight was lifted from the crust of the Earth, and the Earth underneath the ice sheet locations actually began to rise. And we're on the other end of that seesaw. So as those lands rose, our land is sinking or subsiding. And so if we look around the globe, this is a map of what we call isostatic adjustment of the Earth's crust due to the weight of the ice. And we see the reds and oranges are places where the land is actually rising. It's actually increasing in elevation as the ice melts. And the areas of blues, light blues and darker blues, are where the crust is actually subsiding. And in New Jersey, we're in that light blue shade, which tells us that we're subsiding anywhere from 1 to 2 millimeters per year, depending on our location. So we have these two components of sea level change, and together, when they're combined, which the global forcing of change due to heating and ice melt, and the isostatic adjustment of the Earth's surface, we call that a relative sea level change. And so in New Jersey, that's why we're seeing upwards of 4 millimeters per year in sea level rise due to those two components. So what can we expect in the future? So, well, we know the climate scientists are projecting with their models different warming scenarios depending on how quickly the industrialized countries of the world can reduce their carbon dioxide emissions or their greenhouse gas emissions. There's more than just carbon dioxide, right? And right now, it doesn't look very hopeful. We're actually along the red line of high growth emissions, where we really want to be at the low growth emissions. But we know that if we continue to warm the atmosphere, that the ocean will continue to absorb heat, and the seas will continue to rise as the glaciers melt. And so the plot here on the left is the change in atmospheric temperature. And then on the right, we have a projection of how sea level may respond to those changes from 2014. And so we're expecting anywhere from 1 to 6 feet of sea level rise, depending on which mission scenario plays out. The thing is, when we look at these curves, we kind of are projecting somewhat of a linear or maybe slightly parabolic change. But in reality, what scientists now are starting to agree upon is that we will most likely see those melt pulses just like we saw in the past, 15,000 years ago, where we'll see rapid increases due to the collapse of glaciers or the collapse of the ice shelves in Antarctica. If you followed the news recently, there was tremendous flooding in northern India along the Himalayas due to a glacial collapse and flooding downstream of that glacier. And they're the kind of events that are probably more likely than just this gradual increase in sea levels. So one thing we have to remember in New Jersey is that our sea level actually locally is rising faster than the global average. So that puts us even in more jeopardy. Okay. So there's a lot of concern about what's happening in New Jersey for sure. The New Jersey Department of Environmental Protection pulled together a task force to review potential sea level changes along the New Jersey coast over the next 100 years or so. This was led by Dr. Bob Kopp up at Rutgers University, one of the leading experts in sea level rise changes in the world. And so what they've done is they've looked at all the possible emission scenarios, and they created a probability or a chance of exceedance of certain water levels over time. And so I'm just going to focus in on the 50% chance. So basically the research says there's a 50-50 chance, whoops, go backwards, by 2030 that sea level will rise about 0.8 of a foot above its level in 2000. And by 2050, there's a 50% chance that it'll rise 1.5 feet above its 2000 level. So, and you'll notice there's no ranges due to emission scenarios there. And that's because at this point, the science is telling us that there's already so much heating baked into the oceans that it does not matter what we do with emissions out past 2050. We're already going to see sea level changes of these magnitudes. Now, there's a little bit of uncertainty around those numbers. You'll see that they range from an almost certain chance of 0.3 of a foot rise by 2030 to a very low chance of 1.3 feet by 2030. And so that's kind of the uncertainty in the modeling. If we go out to 2100, let's say, now we see the emission track we're on will determine how high those seas will get. And so there's a 50% chance that we'll see maybe 3 feet of sea level with the low emission scenario, and almost 4 feet with the high emission scenario in 2100. And if we look at the high end, the very last row of this graph, this is the ice collapse melt scenarios where we're seeing maybe almost 9 feet of sea level rise in 2100. Now, to give you a sense, our barrier islands in New Jersey, their average elevation is 7 feet above sea level. So, well, what does this really mean for us along the coast and for our coastal communities? And we have two problems. One is we have the sea level rise issue that's going to continue to creep closer and closer to our dry lands. But we also have storms like the one that occurred this past week that come up the coast, and they create what we call meteorological tides or storm surges with the winds and large waves that they generate. And so if you really want to understand how quickly flooding will increase along our barrier islands and our coastal lands, we really need to look at both the sea level change, but also the storm frequencies and storm tides. So I just want to do a little case study. We've been working with the community of Ocean City, New Jersey, to document and understand the flood impacts from both sea level changes and storms. And so Ocean City is, if you're not familiar, it's in southern New Jersey, Cape May County. It's about 10 miles south of Atlantic City. And it's a very typical barrier island complex that we see in southern New Jersey. Very low lying. Again, the highest elevations are at the dunes, and then the average elevation is about 5 to 7 feet on the island itself above sea level. And I want to focus in here on an evacuation route. So I always like to look at these key parts of the island. This is a roadway that leads to a bridge to the mainland, and it's very low. Its average elevation is about 3.5 feet above today's mean sea level. So it's very close to the still water level. And I want to focus on a storm. This isn't the one that happened last week, but it's almost exactly the same as what happened last week. This is a storm that occurred in March of 2018. Very similar with winds and flooding that we observed last week. So we took a look at this storm and the frequency of flooding that may occur at this roadway in Ocean City. And so this is a graph of the observed water levels during the period in March 2018 from the Atlantic City tide gauge. The Atlantic City tide gauge is actually on the ocean side of the island on Steel Pier, and it was installed in 1911. So the datum here is mean sea level. So everything is referenced to mean sea level, which is the average between the low and high tides. And what the little bars at the top, the colored areas of the graph, are where the National Weather Service has denoted minor flooding should occur, moderate flooding should start, and major flooding should start. And so during this time period in March of 2018, what we see is that that storm was able to generate water elevations in the minor to moderate flood ranges and cover the roadway in Ocean City for 12 tides, and reached moderate flood level on 2 of those tide events. The red line indicates the elevation of the Roosevelt Boulevard. So if we wanted to just tease out the impacts of sea level rise on this storm, we can adjust the water levels back to sea levels at some prior date. So what I've done with the data here is I've gone back 57 years from the time I did this analysis, basically to 1962. So I've adjusted all the sea levels back down to their 1962 value, which is about 9 feet lower than it was today. And the reason I did that, there was a very, very significant storm event in 1962 that occurred in March, which was the storm of record in New Jersey for at least until 1992. And so the blue lines here on the graph represent the water levels observed in the 2018 nor'easter. The red lines indicate what the same storm would have done if it had occurred in 1962. And so what we see is that only a few of the tides reach minor flood stage, maybe 3, 4 if you count 1 on the end, and none of them get above the moderate flood level. So that's the impact sea level had just in changing the amount of times that road was flooded in 2018. And we can look at this in the other way too. We can project out 57 years. So this is another 9 feet of sea level. And I have to say, these are based on the historic linear trends we just looked at from the tide gauge. So these don't include any of the climate models or any emission scenarios, just what we've observed over the past century. And if we look out into 2074, now we see the same storm indicated by the red lines would reach major flood level on 2 of the tides and would have certainly created minor flooding for every tide during the storm. So that's how sea level is playing into coastal stormwater level changes. And so what's occurring really is that our coastal storms are becoming more intense because sea levels are higher. It's like, I think this analogy is used quite a bit, but it's like raising a basketball court up without raising the baskets. And so you get closer and closer to the basket as your floor continues to rise, right? So it doesn't take as much to dunk. So we can actually take a look at all of the observed water levels at a tide gauge. So I'm looking at 20 years of data from Atlantic City in this case. And this record includes both the astronomical tides as well as all the storm surges. And so this gives us a picture of what the true water levels along the coast are doing. And within there is a sea level rise component, but this is really showing us how those tides are affecting the communities. And what we can do with these data, we can take those 20 years of data and we can look at how many times the water level was a certain elevation above or below mean sea level. And we can figure out the probability of that occurring over that 20-year period. And so I've done that with the data. And what I'm showing is basically for any given year in that record, how many of the tides in that year should be above a certain elevation relative to mean sea level. And so the blue curve is the number of tides. And on the x-axis is the elevation above mean sea level. That's the 0. And these are the number of tides. And so we have 2 high tides per day. So roughly 735 high tides a year. And what the data shows us from Atlantic City is that we should expect every high tide to be about 1.5 feet below mean sea level. So there are high tides that actually never reach mean sea level on very windy days when the wind is blowing from the west. It also tells us that we should expect about 50% of the tides, the high tides, to be 1.9 feet above mean sea level, and that 25% of those tides should be maybe 3 feet above mean sea level. And so if we superimpose the tidal range on here, we can see that the high tides fit within the tidal range, so that's great. And but we actually have out here on the edge, if it opens for me, seems that there we go. Out here on the tail are the tides that are generated by the coastal storms outside of the tides. And so if we look at this 20-year record and we superimpose the elevation of Roosevelt Boulevard here, we see that on any given year, we should expect Roosevelt Boulevard to be flooded a certain number of times. And if we take a look at that number, it's actually 24. So we should expect that the storms, if they continue as they have in the past, and that's a huge assumption, so I might be wrong there, we should expect the road to be flooded this year 24 times. So now I can shift the storm tides or tides in general, the high tides, by adjusting them for the projected sea level in 2030, 2050, and I've done 2100 for all 3 emission scenarios. And a couple of things to point out in this curve. One is that it's parabolic in nature. It's not linear. Things aren't changing linear. They're changing in a parabolic manner. And whoops, let me go back. And that as we shift to the right on the graph, it's taking less and less water to cover the roadways. And so what does this mean? So we can, again, look at the elevation of Roosevelt Boulevard, and we can see here that today we expect a 24 floods per year on the boulevard. But by 2030, just looking at that shift in mean sea level from the 50% likely range, we should expect that road to flood 130 times. By 2050, the gray line, we should expect 300 times. So almost every other high tide should flood the road. And then even in the low emission scenario, almost every tide will flood the roadway in 2100. And for the other 2 emission scenarios, it's almost certain the roadway will be underwater every high tide. And so this is a real concern. And how does the community adapt to these changes? Because they're not going to occur just instantly at 2100. These impacts are going to occur, and they are occurring right now. And it's going to just get increasingly worse. We can look at the data in terms of how many times per year we should see flooding occur based on the year. And we can see the the existing trend, even the existing trend has us at over 100 high tide floods per year out at the 2100 range. And the real question is sea level going to continue rising linearly? And that's a question we're not really certain about. The satellite data that NASA collects is indicating that we're seeing an acceleration of sea level rise. So we're seeing the hockey stick effect, if you will, like we see in the temperature data, but not as dramatic. One of our issues is it takes 20 years of tide gauge record observations to actually recalculate the mean sea level datum. So we should expect in 2024 for NOAA to actually complete its reanalysis of the tide gauges in New Jersey to give us what the true change in mean sea level has been over the last 20 years. But if we look at some projections, these are different locations along the eastern seaboard. Sandy Hook and Atlantic City are up here near the top. And these bars represent a number of nuisance floods. So this is just sea level change generating high tide flooding without a storm. And we see that, again, it's not a linear change. These are exponential changes where we would expect to see a shift from 24 times a year of high tide flooding to over 100. So just want to finish with this other problematic issue we have along the coast, and that's rainfall. And so we do expect, and the DEP is actually projecting for a 125% increase in rainfall as climate changes plays out in New Jersey. And that's going to add to an additional flood threat for our coastal communities. And this is an area that's not well understood at this point. There's a few articles out there in the literature that look at the joint probability of coastal flooding with sea level rise changes and rainfall. It looks like the relationships are complex. This is a probability curve, tide levels on the y-axis, sorry. And the X is rainfall amount. And you can see that, it almost becomes linear as the tides get higher, the tides are driving the flooding. But we do have this sweet spot where rainfall is going to really increase flooding where we shouldn't have seen flooding in the past just due to the tide. So one way we're trying to understand this impact in New Jersey is to work with communities like Ocean City to get a better understanding of what we're seeing in our coastal communities. This is the Ocean City Flooding Committee. That's a committee set up by the city to investigate flood mitigation efforts. What we've done with them is we've provided them with rain gauges to measure rainfall at different locations around the community. We've also worked with a organization called IC Change to get them a handheld app so they can actually take pictures and record observations of flooding, just like the picture below it here. We've worked with the city to install bands on certain telephone poles that indicate the minor, moderate, and major flood levels at that location. So we get a little bit of a visual sense of how deep the floodwaters are for any given picture. And we're beginning to assess this data. We have 2 years of data now. We've been collecting since October 2018. And what the citizens data is showing us is that flooding, like the image in this picture represents, is occurring about 45 times per year. And so we looked at the storm impacts on Roosevelt Boulevard and said, hey, we should expect flooding 24 times per year. But when we add rainfall to it, we're seeing flooding occur much more frequently than we expect. And so just to conclude, what the data is showing us is that just due to sea level rise alone and the historic water levels measured along our coast, the number of coastal flood events is going to change significantly, even with very small changes in sea level. And this is going to increase the future flood events. Even if we don't increase the sea level rise rate, we're going to see these impacts no matter what. And if sea level does accelerate, its rise accelerates over the next few years or decades, we should be really prepared for almost daily flooding within our coastal communities. And again, we're really just starting to understand the rainfall component to this tidal flooding. And so I'll leave you with this picture. We have some hard decisions to make along our coast. and we don't have a lot of time. And so we really need to, as a community, really think about what we want our coast to look like and be like in the future. And with that, that's it. Thank you very much.
Thank you so much, Tom. Really appreciate this. Absolutely fascinating. So if you have questions, now's the time. There were a couple questions in the chat that I want to address. Let's see, where did I go? One of them was by Professor Mackey, and she has left. Someone asked, what caused the ice to melt in the Cretaceous period? And then Robert, I'll get to your question.
Right. So I'm not a true climate scientist in that sense, but certainly the concentration of carbon dioxide, the greenhouse gases in the atmosphere, caused the average temperature of the planet to be well above where it is today, 80 degrees Fahrenheit. And with that amount of average heating or average heat in the atmosphere and oceans, the ice melted completely. So what drove that in the Cretaceous period, I'm not certain. There have been past events in the geologic record where huge blooms of phytoplankton, huge respiratory releases generated large rises in carbon dioxide and changed climate. But I'd have to look into that to really understand what happened 100 million years ago.
Okay. Robert, you had a question, so unmute yourself.
Okay, I had a question. How does all this data translate into actual policy decision? Because I work with Meredith Comey at Baykeeper, who you had that resilience meeting with last week, and we're working on that living shoreline at Naval Station Earl. But to try and get that to be accepted on a wider scale, there always seems to be some kind of roadblock. And does the flooding and the storms help expedite that process at all?
Expedite this action
Of some kind of new policy being written or even looked at.
Yeah. Yes, I would say it happens quickly, but we are right now lucky that the state has over the past year been working on a climate change resilience strategy for the state of New Jersey, which includes a strong portion of that is coastal issues, coastal resilience. And they are working on new rules or changes to their existing coastal zone management rules, which are designed to increase the opportunities to use things like nature-based features for resilience. So they are expected to come out on Earth Day this year, both the new rules, which I think there's a year that the public can comment on those new rules, and the strategy itself. We're not exactly sure what opportunity there will be to comment on it, but we do expect both of them to be released on Earth Day.
Okay, thank you.
Yep.
And just as a reminder, this is being recorded, so we'll let you all know when that is uploaded to Brookdale's YouTube video. Someone else asked, hold on. I'm trying to scroll down. Is it possible that we are experiencing another event?
I think I lost you, Judy.
Yeah, I don't know what happened. But my question was, is it possible that we are experiencing another event just at a faster rate because of us humans creating more carbon dioxide?
Yeah, certainly. Most scholars believe that we humans now are the dominant influence on climate, and so you often hear people refer to this period now as the Anthropocene to indicate that the driving changes on Earth are being driven by us. And so, and that's pretty evident in the data that we see in terms of greenhouse gas emissions and warming. How the cryosphere responds, so that's the ice and oceans, is something we're just now trying to understand. A big part of the International Panel on Climate Change work over the past few years has been to focus on how quickly we should expect the ice to melt and add to sea level rise. That's a big unknown right now. But we also, we are driving it, but we also are smart enough to figure out how to reduce its impacts. And if we were to start to change behaviors and change a lot of how we do things, including maybe using carbon sequestering technologies, we may be able to figure our way out of this plight we have ourselves in right now.
Okay, thank you.
Does anybody else have any questions for Tom?
So I guess what I'm just sort of curious with is that I know that there's a lot of I guess this is a bit more of a but let's say you want to explain this information to someone else that might not be as well versed in climate change. How might you do so in a bit more of a different way? Because I know a lot of people probably just get a little thing of like, oh, it's just the same old story. More CO2 leads to sea level rise, and sometimes I think some people might find that as white noise. So it's like, I guess, how would you sort of explain that like a little differently so that way people get a bit more invested and, are more willing to be involved?
Yeah, that's a great question and point. I have found in my career that the more you can make it tangible to the person in their location, the better. And so what I've done in this presentation, a lot of it is focused on a single community that has observed flooding. They understand flooding. They live through it all the time, and use the historic data to. I don't tell in this presentation, when I usually go into a community, I don't include the beginning part of what's driving sea level rise due to all these climate variability. I start with, this is the tide gauge record at Atlantic City, and this is what it's telling us over the last century, and this is the impact of that. And sometimes we don't even get into the climate change numbers. We just look at that. So that's a way. I think the more you can connect somebody's personal experience to the broader climate change discussion, the better, because people will admit, I get two responses, and I, to be honest with you, I grew up in Ocean City, so I know there's these two responses. One is, you're living on an island, you should expect to get your feet wet because it's going to flood, right? And that's true. I've lived through many floods on the island, but what's not true is the fact that these flood events are becoming much more frequent. We're seeing 45 street ends a year flood because it's just the water can't drain off the islands anymore at high tide, and that wasn't the case when I was there 40 years ago.
Anybody else have any questions?
I have a question.
Go ahead.
You already touched base on this. I joined in late, but I heard about what was happening in Bayhead this past couple days since the big snowstorm. My mom showed me photographs of what was happening, and I wonder if you have any explanation of what exactly caused that. Was it just a natural thing, or is it has to do with climate change, or just curious.
Yeah, so that's a tough one to tease out weather from climate in an event like that, because those storms aren't uncommon off the New Jersey coast, right? We've had many nor'easters over the years, and the beaches that were constructed by the Army Corps of Engineers are actually designed with sea level rise considerations in them. So every time they come back to rebuild that beach, they build it a little bit higher. They're adjusting for sea level all the time. But one of the things that happens along our coasts is when we have very large waves and very high tides that allow those waves to get across the dry beach. That's when we see a lot of erosion. And the longer that storm takes to pass also plays into that. So I think we had about 5 high tides last week, with wave heights up to 20 feet high off of Barnegat Inlet that attacked the beaches basically. But they're designed to do that. They're kind of nature's speed bump in a way. Even natural beaches, what happens is the erosion pulls the sand out into the sandbars, and the beach is very good at becoming a natural dissipator. So it makes that sandbar just far enough offshore so the waves that break at the end of the storm aren't doing any more erosion. They have all that surf zone to come in. And so what we, they're pretty badly eroded right now, but we do think, if the winter has no more bad storms like that, although I think we're getting one this week, we should see the beaches recover somewhat before the summer. So every calm day you go to the beach and you look out and those little waves are breaking, those small waves are the ones that act like bulldozers to push the sand back. And so for every bad day, all those little good days are pushing sand back towards the beach.
Anyone else have a question?
Thank you.
You're welcome.
Anyone
Yeah,
else?
I have a question. I was wondering, it seems like recently on the news, there have been lots of individual stories. This is kind of adjacent to sea level change, I think. Individual stories of these quote unquote climate refugees in California and Colorado, leaving after whatever it may be, primarily wildfires, right? I wonder if you could talk about what implications that might have for New Jersey in terms of how that might play out in terms of demographics and economics and what that means for the state in the future.
Yeah, great question. And actually, I'm on part of a research team that Sea Grant's a member of, where we're looking at this across the country. It's climate-driven migration, right? And what should we expect in the future? And there's a number of drivers, right? There's storms like Hurricane Maria created a tremendous climate-driven migration out of Puerto Rico into Florida. You mentioned the wildfires. There's other places like Isle St. John in Louisiana where they're just going underwater due to sea level rise, and they're actually moving an entire indigenous tribe off that island. And it's been a very difficult process to actually relocate that community. This is going to become more common, and how do we respond to that? And New Jersey is it's a head scratcher, right? Because it's a mix of full-time residents along our coast, and it's a mix of second homeowners and vacation rentals. And so it's a little different economy, right? Especially if you don't live there. I think it's harder to be impacted by these things if you're not there every day, and inconvenienced by not getting out of your house because the streets flooded. And you can still rent it in the summer. And so for those kind of communities, I think, and this is just a personal opinion, there's going to be a break point where we'll see another really catastrophic storm event, unfortunately destroy and damage these homes and communities. And we're going to have to really ask ourselves at that point, is it responsible to rebuild here? Is the market still going to drive this tourism industry, or should it change? I don't think it's going to be gradual sea level rise. I don't think it's going to be nuisance flooding. It's going to be the next really big storm. And in our case, many of those second homes, they'll just go back. They won't have any impact. It's really our marginalized communities that are going to suffer. And they're the ones that, at least in our research, we're starting to focus on. We're focusing on those communities that have a pretty high proportion of the population that have no means to move, have no means to migrate somewhere else if things change. And that's the group that we're focused on in the Mid-Atlantic and Northeast. Excellent question, by the way.
Thanks for answering it.
Yeah.
Anyone else have any questions?
Yes, I got a question.
Yep.
Is there any way that possible, maybe, that because it's all this global changing, that we might have like tsunamis or mega tsunamis? And also, is it naturally supposed to happen like this because of the Earth supposed to renew itself every 25,000 years, as some people think that could be going on right now?
So two questions there, right? So I'll answer the
Yeah.
first one.
Mhm.
Mesotsunamis and tsunamis. The geotechnical processes are typically not climate driven, but that's not totally certain. There are certain things that if a glacier caves, we could see tectonic changes that create a minor earthquake and a tsunami. So there could be a relationship between these rapid changes in the continents and what may happen with tsunamis. And most people don't know, but it's actually more probable to have a tsunami reach our coast in New Jersey than a hurricane. If you look at the history, that most of them are very small, but
Yeah.
certainly we've had impacts from Canary Islands, the collapsing part of the island. It created a tsunami that reached us in the 1700s. So we do get tsunamis. Matter of fact, the one that happened in Southeast Asia in 2004 reached us. It was just tiny. So,
Yeah.
but anyway, that's a great question. The other part is the cycles, right? So a lot of people wonder if, because the Earth has gone through these cycles in the past, and I showed you one, is there a cyclical component to this? Maybe our position around the sun, based on certain time periods, we're actually cooler than warmer. That's a part of it, but I think the rate of change we're seeing now is just really points the finger at our impacts on the climate. Those other changes happened over millennia, and we've been able to modify our climate in centuries. So that's something that's never been seen before, on at least in Earth's geologic history. And so, but it is a good point. There are these natural cycles that do create changes.
Yes. Thank you.
You're welcome.
Thank you.
Great questions. Anybody else have a question? Okay, Tom, I'm going to ask you my question. I've already asked him just in case, but I wanted to ask you, how in the heck did you get into this career? We have a lot of students here, so we want to know.
Yeah. So I told you I grew up in Ocean City, so that's part of it. I grew up on the beach. Always loved the beach. When I was in high school, started surfing, so that was another reason. So I was really a beach bum to start with. And I went to college to become a mechanical engineer. I had no idea what engineers did. My guidance counselor said, "Oh, you're good in science and math. Go be an engineer." And so I got to college and I'm like, man, does this suck? This mechanical engineering. I don't want to design a ball bearing So I was contemplating, what I wanted to do. And there's this little known aspect of civil engineering, and civil engineers are the ones that build bridges and buildings and roads, called coastal engineering. And so it was all about port and harbor design, breakwater facilities to protect boats, and this new idea, which was not tremendously new at the time, but really only a couple of decades old, of coastal engineering, which was the use of natural coastal features, restoring beaches and dunes, and to provide protection to communities. And so I was like, well, if I wanted to be a beach bum the rest of my life, I could just go into this field. This would be great. I could be in some warm tropical paradise all the time and working. So that's how I chose the path towards the coastal engineering, which kind of combined a passion with an avocation, right? A vocation, I should say. So, and it's worked out for me. I'm not in a tropical paradise, but it's still great working in New Jersey and being able to help New Jersey, the communities I grew up in, and the environment that I really loved all these years. And there's been a shift. What's been interesting to me is that the early part of my career was really focused on the Atlantic Ocean shoreline. And since Sandy, we have been doing a tremendous amount of work, just like Robert mentioned, in the coastal bays and estuaries, and trying to really understand how those natural features are providing protection to our communities, and what do we really need to do to restore them so they can function in the future under these increasing sea level rise scenarios. So that's really really exciting work right now.
Great. Can you talk to the students and the community about how to get involved if this is something that they're interested in working with?
Wow, so there's a number of ways, and Robert mentioned one. There's plenty of nonprofits working in this space. There's the Nature Conservancy, there's American Littoral Society, there's the Baykeepers. They always look for volunteers to put oyster shell out in their living shorelines, and it's a way to meet people, learn about what's going on in the field and in New Jersey. So that's one way to be engaged. The other way is to work within your community. What we're doing with Sea Grant is we're really trying to roll out more community science opportunities where we're going into partnerships with the communities. I hate to say citizen science because it makes me sound like I'm making you collect my data for me. But we're trying to solve a problem together. And in the case of Ocean City, it's the flood issue. When we started working with them, their anger was directed at the city for not investing in infrastructure to improve the drainage so they wouldn't flood. They didn't have an understanding that the sea level itself was driving a lot of this. And so we've begun to look at ways to monitor our environment as a way to partner with communities. And I know there's a watershed ambassador in Cape May County that's trying to do some programming around that idea. So we're looking for opportunities like that too, where if looking at communities, getting engaged in an issue and building some really great work. And as a career, there's environmental sciences and there's really this great synergy right now between engineering, environmental science, biology, because as we look at these natural restorations and natural features, it's not just one profession that's going to solve these issues. There's a real synergy among multidisciplinary teams now to look at these ideas. And there's a way in there, even from the social justice perspective. There are many different talents needed in this space right now.
Tom, somebody asked, do you think I can do something similar with environmental engineering? This person's looking at their options at the moment.
Absolutely. Yeah. Environmental engineers, and I don't know specifically what courses you have taken, but, traditionally they're the ones that had their degree or their field traditionally has solved problems in our environment that were driven by pollution. But there's been a realization among the environmental sciences and engineers that those kind of projects are still important, but a more important side of this field is going to be climate adaptation and climate adaptation systems, and how do we create and restore natural systems to function, and that's a real growing field.
That's great. And looking for schools that have those majors would be a good thing to explore. Anybody else have anything? I have one more thing from the library end, and then we'll log off for now. Tom, would it be okay for them to contact you if they have any further questions?
Yeah, absolutely. Can
you put your email in the chat?
Sure.
Do you still surf is my question.
I do, but not when it's this cold.
No. No, that would be a little rough. Okay, so Tom's going to put his email in the chat if you would like to ask him further questions. And somebody asked about looking for links to volunteer for places and some extra information. So I'm going to take down those people's names to get them more information.
Okay.
But I'm also going to send out or try to send out a page for environmental opportunities for you to volunteer in your Monmouth County or wherever you're from. So you can email me. This is my email address. My name is Judy Younger, and my email is jungar@brookdalecc.edu. I'll put that in the chat in a second if you want to get a list of volunteer opportunities, and I will work on that. The last thing I wanted to share, and I'm going to share my screen if you don't mind. Can you stop sharing, Tom, for a
Oh,
second?
am I sharing?
Yeah. I wanted to go to Brookdale. Can you guys see the Brookdale page right here? Okay. So if you go to my Brookdale and the library, so there's a link to the library at the top of the page. There is a fantastic research guide. If you go down here to research guides right here, and then scroll under current topics. And there is a Global Citizenship Project environmental issues. And this is a research guide that my coworker Val Bonilla, who is the library liaison to the STEM department, created. If you're a Brookdale student, you will have access to all of these resources. These are library databases. If you're a community person, there are websites listed on here that can be very helpful to you. So please feel free to take a look at this research guide. It is really, really good. And it provides a lot, and even if you had environmental research papers, there might be. And interestingly enough, Tom, one of the history professors is having students write about environmental issues in history. And I work with that professor. And so they're learning, all of these terms that you mentioned in your lecture. So, but dealing with history. So it's really a lot of the faculty in multiple disciplines are,
I think we lost her again.
I think. I wonder if I can. I don't know if I can get the screen back. Oh, there she is.
Oh, there I am.
Okay.
I live in Metuchen, which has the worst internet access in the entire universe. So I'm just glad I made it this far. So those are the two things that I'm going to do. Make sure you look at the research guide. And if you have any comments, thank you, Janice, for putting that in the chat. If you have any comments, questions, or anything, you can email me, Judy Unger at JUNGER. Let me put it right in the chat right here. And as far as future events, we are going in March, going to be having one of our own Brookdale faculty talking about her novel that she wrote about from a teenager standpoint about Superstorm Sandy. So that will be held Thursday, March 11th at 3 p.m. So if you're interested, look, there's already been some advertising about that. So look for that to come up. And then we're also going to be doing a screening of a DVD that's going to be talking about through Netflix streaming about climate change and the LGBTQ community. So those are some of the things that we're going to be doing looking further down the road. Thank you so much for you guys for attending. I'm so pleased with the amount of people that showed up and the interest and the, all of the different things that you can do. And thank you so much again. So let's give Tom a round of applause.
Thank you.
Or you can put your little reaction in the chat like this. And I hope you really enjoyed it. If you were late coming in, this is going to be recorded. So once the link is uploaded onto Brookdale's TV, I will make sure that an announcement is passed out to the whole college community. If you're a community member, you can email me, jungar@brookdalecc.edu for that link. Thank you so much for attending, and I'm going to stop right now.
All right. Thank you.
Tom, if you'll just stay on just a second.
Sure.
See you guys later. Bye-bye.
Thank
Okay,
you.
Bye bye, guys.
Bye.
Thank you. All right, thank you so much.